Alrighty, class. So for today, what we are doing is we're talking about 8.2, our special right triangles. Okay. Now these triangles, as per the name, are special in some sort of way. And so what we're going to do here is we're going to identify what those two special triangles are. Get to the right triangles. And the first one is the 45, 45, 90 triangle. It's an isosceles right triangle that can be formed by cutting a square in half diagonally. As you can see, this is our square and it's cut in half diagonally. And that is our first kind of triangle. You'll see the theorem 9.4 here. And of course, that is our 45, 45, 90. Now, something I want us to do too is look at these here a's and the a times the square root of 2. I want you to replace those x values and whatnot with the a's. Okay, any x value you see replaced with a, it's just going to make a little bit more sense for us later on. Okay, and so this first theorem says that the hypotenuse is actually equal to the leg times the square root of 2. And that's why we replace both the legs with a, and the hypotenuse is a times the square root of 2. But of course, that's not our only special right triangle. We also have what's called the 30, 60, 90 triangle. Now, this one is a little bit trickier, but just a smidge more. Okay, so what we want to do is we want to take the shortest leg size. Okay, the shortest leg size, we'll call it A. But something to remember is that the shortest leg size is opposite of 30 degrees. Okay, remember back in Unit 6, we talked about the shortest angle goes with the shortest side, the largest angle goes with the largest side, and whatnot. This is the same concept here. Okay, so this 30 that we see in our triangle goes to the opposite side, and that's A, which is our shortest leg. Our shortest leg times square root of 3 equals our longer leg. That's why we have an A times the square root of 3. And our hypotenuse is 2 times larger than our shorter leg. So that part is easy. That square root of 3 is a little bit trickier. Okay, so as long as you have these two concepts in our mind throughout the entire lesson today, you'll be just fine. In our turn and talk, okay, 45, 45, 90 triangle above is an isosceles right triangle. Can we think of any other possibility where there's another isosceles right triangle where the two acute angles are not 90 degrees? Why or why not? And the answer is pretty simple, actually. Let's remind ourselves what an isosceles looks like. First thing is isosceles has two congruent sides. Well, if it has two congruent sides, it also has two congruent angles. And we know this is supposed to be a right angle, and we can't have two right angles. That doesn't make any sense. So this angle here is right. And so that only leaves us with 90 degrees to split amongst two angles here. And you know what? It just doesn't make sense. No, there are no other right triangles that are isosceles. Okay, no other right triangles that are isosceles without 45 degrees. It just doesn't make sense for us to do that. Okay, and so we move straight into example 1 here. In example 1, we have a couple of things to think about. First, our CFS. We must determine if it's a 45-45 or if it's a 30-60-90 triangle. Okay, we must figure out if it's one of those two triangles. Then we're going to take those values and we're going to actually change them a little bit to see a little bit more of what we saw in the theorems, and then we're going to solve. So in this problem A here, I see a right triangle. I have a 45-degree angle, which means my other angle must be 45 degrees as well. So these are congruent. So I've determined I have a 45-45-90 triangle. Then, because I know I have that 45-45-90 triangle, I'm going to replace some values. So this side length I don't originally know. I'm going to change that to an A. then this 8 is going to equal a. Okay, that's my legs. My legs are congruent to each other. Then my x, my hypotenuse, is a times the square root of 2. So if I already know that a equals 8, and I know that x equals a times the square root of 2, I'm just going to replace those values. X is going to equal 8 the square root of 2. And that's it. That's our answer. And it's already in simplest form. Even better. You're going to do the same approach with b, but now I have the hypotenuse. I see here that I have my two x values. They're the exact same, which means that these are 45, 45 degrees. So I'm dealing with a 45, 45, 90 triangle. I know that my 5 here, 5 times the square root of 2 is equal to a times the square root of 2. And I know both of these x values are equal to a. So what I'm going to do, I'm going to solve for a. A, the square root of 2, equals 5 square root of 2. Divide the square root of 2 on both sides. That will cancel out on both sides. And I get my a to be 5. So my x must equal 5. Okay, again, renaming those things, that's where our equals comes in. Renaming those things is going to make things a little bit easier for us so that we can just keep the notation of that a stuff. Okay, that's definitely going to be the easiest thing for us. Just like every other time I've recorded, make sure you at least try some of these problems on your own first prior to looking at the answer here. So for example here, for example 1, I definitely think you should try this on your own. You can definitely get it. So try it on your own first and see if you can get it. Then you're going to find the value of x, right, in the answer of the simplest form. If I know that these two are congruent, then I know that the angles are congruent as well, which means I have a 45, 45, 90 degrees triangle, which means that 22 is equal to a, 22 is equal to a, x is equal to a times the square root of 22. So if I know that a equals 22, and you can see how easy this actually is, and I know x is equal to a times the square root of 22, or sorry, square root of 2, then I know that x is equal to 22 times the square root of 2. And that is simple enough. Now with b, same approach, right? It seems like we always have those 45, 45, 90 degrees triangles. Okay, I know my x is a. I know my 10 times the square root of 2 is a times the square root of 2. And I'll just solve. 10 square root 2 equals a square root 2 divided on both sides. We get x, or sorry, 10 equal to a. But because I already know that a equals x, I can say that x equals 10. Yeah, it should be really simple, really easy for us right now. On to example 2. Example 2, we finally get that 30, 60, 90 triangle. Yes, awesome. But now we gotta do some steps a little bit differently now. So remember back to the theorem. The theorem said if we take the 30 degrees, it is the shorter angle. That means that it corresponds to the shorter side. That means that x is equal to a. We already know our hypotenuse is y, and that's twice as large as a. Which means that the 9 here, which is the opposite side of our 60 degrees, is equal to a square root 3. Okay. So now that we have it like this, we must figure out what a is first in order to figure out my x and my y values. So I'm going to put 9 equal to a square root 3, and I'm going to solve for a. Well, I take the square root of 3 on both sides. That one's going to cancel though. I get a equals 9 over the square root of 3. But we don't want it to be written out like this. It just looks ugly to us. We don't want it written like this. Okay, so what we're going to do is we're going to multiply. Okay, we're going to rationalize our problem. Think back to the last lesson. We'll rationalize this, multiply by 1. we're going to multiply by the square root of 3 on both the numerator and the denominator. We get 9 times the square root of 3. We know square root of 3 times square root of 3. Those will cancel out, and we'll just be left with 3, which we can still reduce. 9 over 3, we get 3 square root of 3. So all that work to say that x is equal to 3 times the square root of 3. And of course, because we know x is equal to a, and we know a equals 3 times the square root of 3, I'm going to take that value, a, and multiply it by 2. So 3 times the square root of 3 is just going to be 3 times 2 the square root of 3. And this is all just multiplication, so you can just multiply any way you want to. And so my y value now is going to be 6 times the square root of 3. Much easier than we may think. Again, try extra example 2 on your own. I'm going to use a different color now. I'm kind of tired of seeing red. But here, we have another 30, 60, 90 triangle. We know that because that second angle there is 60 degrees, that this must be 30. If this angle is 30, that makes y our a, x our a times the square root of 3, and 30 our 2a. This is actually much simpler than we think. If we know that 30 equals 2a, solve for a. Divide by 2 on both sides, we get a equals 15. Well, if a equals 15 and a equals y, then that stands to show that y equals 15. And I'll solve for my x. X is equal to a times the square root of 3, but I know a is 15. So I get this value as my x. And look at that, super easy, super simple for us. Okay. About halfway done with this lesson now. We have about 4 more examples. Here is where it can get really tricky really fast, okay? So what my suggestion is to you is to make your triangle when you redraw, because look at our CFS. It says redraw is the first thing to do. My suggestion to you is make your triangle as big as possible without taking too much space. For example, taking up as much space as possible, but not taking up everything. Okay, so look, I have everything in the middle here to still work with. But I'm going to remake this yield sign. Okay, the road sign is shaped like an equilateral triangle. Estimate the area of the sign by finding the area of the equilateral triangle. Well, remember, equilateral triangle means that all of these sides are congruent. So if one side is 36, then every single other side is 36 as well. Okay. But it wants the area, okay, the area of the equilateral triangle. An area is going to equal 1/2 times the base times the height. Okay, so we need to find a height. But think back to our unit 6. And remember that the height is also named the altitude. Okay, since it's named the altitude, we know we start at one angle and we go to the opposite side of that angle and we make it a perpendicular segment. Okay, but before we keep going, okay, again, this is where it gets really tricky. What we're going to first establish is that we know that these angles are congruent. Okay, we already know that those angles are congruent. They're all 60 degrees. Okay, that's going to be important for a little bit and later on. But if I take the altitude, let's say this is the starting point. If I take the altitude, I'm going to go straight up and make my 90-degree triangle here. And what's essentially happening here is I'm actually bisecting the angle that I started at. So these two angles are congruent now. But I just bisected 60 degrees. So if that was 60 degrees, bisected would be 30 degrees. Each of these would be 30 degrees. And we can go ahead and fill in the other stuff too. Why not? 60 degrees here, 60 degrees here. So because I have this now, I can effectively figure out what my height is. Okay, remember our height here is this blue line. That is our height. That's our altitude. Same thing here. So I can solve for this, but be careful. Remember, I am a perpendicular bisector now, which means that these two sides are congruent, which means I split 36 in half, which means that that side is no longer 36. Okay, let's now redraw this picture in a different color. That's my right angle. This is my 30 degrees. This is my 60 degrees. And I know that the side here on the very top is half of 36, which is 18. I know that this is 36 because it's equilateral, and I'm trying to figure out what that one is. We'll call it X. Well, remember 30, 60, 90. 30 is the opposite side, or rather the opposite side of 30 is 18, which means that 18 is going to equal our A. So equals A. Then our 36 is actually 2A. And our X here, oh, not sure why that erased. Our X here is A square root 3. So once you have that down, you can figure out what our X value is. But remember, this is our height. Remember, this is our height. So I take X equal to 18, the square root of 3. Realize that it can't be simplified any further than this. And now I have found my base and I have found my height. Now everything is good. So to finally wrap this all up into a nice little bow, I get the area equal to 1/2. Careful on your base though, we want the entire yield sign, not half like what we did here on the black stuff or the black triangle here. We get A equals 1/2 times the base, which was 36, times our height, which we established was 18 square root of 3. And once you've done all that, that is going to equal A, our area, 561.184 inches squared. Because we're dealing with area, it's going to be inches squared. Okay. Back to example 3, it's going to work very similarly. Okay, so similarly, in fact, okay, that we're going to do the exact same thing. So we'll first establish by drawing a picture. This quilt is made of a cloth pieces shaped like isosceles right triangles. Remember, there's only one kind of isosceles right triangles. That's that 45-45. The hypotenuse of each triangle is 16 centimeters. Find the area of one cloth triangle. Okay, let's redraw this. We'll say that this is our 90-degree angle. This is our hypotenuse because it's 16. And we know that these angles are congruent. They're the 45-45. And so if I'm trying to find the area of one cloth triangle, right, I still need to figure out what the altitude is here. But before we do that, I need to figure out, well, what is the other side lengths? So think back to our 45-45 90-degree triangles. We know that the hypotenuse is equal to A times the square root of 2. And we know that our isosceles parts, our parts that are congruent, are just A. So we got to figure out what this is first. And in doing so, we get 16 equals A square root 2. We'll divide the square root on both sides, like so. But of course, we don't want that there. We don't want the square root there. And so we'll just rationalize it. (16 over 2) we'll divide into 8. We get 8 times the square root of 2. And that is our A value. But remember, we need the area. And with the area, we need the height. So this is our H. And from here, it's going to make things a little bit easier. Okay. So now that we have this, okay, we know for sure that we have to break up this 16 because we're looking for our height now. And so let's first redraw everything. You know, we have a right triangle here. We know this is 45 degrees, and we know that this is 45 degrees as well. Remember, beforehand, we knew that this was 90 degrees, and that's why we can say that this is now 45 degrees because it was bisected. And we know A now is 8 square root 2, and we know that this value here is 8. We're looking for H. Well, the easy thing here is I already know my hypotenuse. A hypotenuse is equal to A square root 2. And I know this is isosceles triangle. So I know H must be also equal to 8. And that makes things so much simpler for us. Find the area of the cloth triangle. We already said what the area was, or the area formula. So we'll go ahead and do it. A equals our base, remember, of the entire triangle, which is 16. But before that, we had to take our 1/2 here. And then our height, which was 8. After we do all that, you get an area of 64 centimeters squared. That is our answer. Now, in example 4, why is this not moving up? Okay. Here we go. Okay. A tipping platform is a ramp used to unload trucks. How high is the end of an 80-foot ramp when the tipping angle is 35 degrees or 45 degrees? And so the tipping angle refers to this angle right here. Oh my gosh, why is this not working? Why is my stuff not working? Hold on. There we go. We're good. Yep, there we go. We know that the tipping angle is right here. And so that's what we're going to use as our 30, 60, 90 and our 45, 45, 90. So the first one we'll do is the 30, 60, 90 because it's the first that it talks about. We'll remake this graph. We know that this is 30. We know that this is 60. And we know that that's going to be 90 degrees. But keep in mind, the ramp is 80 feet, not the base. So if this is the ramp right here in purple that I'm marking right now, if that's the ramp, then the hypotenuse is equal to 80. Okay. And again, this is our 30, 60, 90 triangle. So 80 is actually 2A, which means the side opposite of our 30-degree angle is A, and our side opposite of 60 degrees is our A square root 3. Well, we could just do this with some quick math. What is 80 divided by 2? 40, of course. But we're not looking for the A square root of 3. We're looking for just height, which is our A. So if we say that A equals 40, then we know for sure that our height H is going to be 40 feet. That problem. But we still have another problem to do. Set up exactly the same with some minor adjustments. We still have our 80 as our hypotenuse, but now we're working with a 45-45 triangle. And so we know that this 45-45 triangle has A square root 2, and that both of these values here are A. So we'll just solve for A. 80 equals A square root 2, divide by the square root of 2 here, and we'll just keep solving. And so what we get as a result is that we get oops, not 80. We get 40 square root 2 feet as our answer. And all we did from 80 divided by the square root of 2 is just rationalize. Okay, no need to go further into that. I think we got that covered. And the last one, example, or extra example 4, we're going to use the same diagram in example 4, but now at the end with a 54-foot ramp instead of a 80-foot ramp. So we'll do the exact same thing. What did I use here? Purple, perfect. So we'll start out with our 30, 60, 90. 30, 60, and we know that this is 54. We also know that 54 is equal to 2a. The opposite side of 30 is a. The opposite side of 60 is a square root of 3. But we don't care about a square root of 3. We know for sure that we're looking for our height. And so we're just going to solve for our height here. We get 54 divided by 2, which is a equals 27, which means our height equals 27 as well. Super simple. The next part, we have our 45, 45, 45. Why did I say 45 3 times? I don't know. 45, 45, 90. And I know that these two are congruent. And I know this is a ramp of 54 feet. And of course, I'm looking for my A's. And I know 54 is equal to the square root of A, or square root of 2 times A. And so I'm going to just keep solving. So 54 over the square root of 2, or rather, I kind of jumped the gun there. I know 54 is equal to A times the square root of 2, but I'm going to rationalize, cancel this out. And I'm actually going to get the answer of H equals 27 square root of 2 feet. And I realized that in my previous answer, I didn't include my units. Maybe we just make sure to include your units as appropriate. And actually, that's our problem. That is all of units, or rather section 8.2. And I'm actually recording this on Friday so that Monday I can work on some other things. So I hope you enjoy this double upload of our 8.0, 8.1, and our 8.2 lesson. So I hope you all enjoy your weekend, and I will see you all on Monday. See ya.